Hi, hello dear students. Welcome to our channel Maths with Panindra. In this video, we are going to discuss about total probability concept. Based on this, I will give two examples. So, how to apply, where to apply the total probability concept. See, first two important results we are going to discuss. The result one, if A, B are mutually exclusive and exhaustive events. We already discussed about mutually exclusive and exhaustive events in the beginning of the videos. Once you go through, dear students, A, B are mutually exclusive and exhaustive events, and E is an event that happens either A or B, then the probability of the event E is, the probability of event E is, how to write is, P of A into P of E given A happens either A or B, they are saying no, or means. So P of A into P of E by A, or means plus P of B into P of E by B. So either A happens or B happens. The probability of E in this, suppose two events are there, like this we can do. Three events are there. A, B, C are three mutually exclusive and exhaustive events. And E is an event that happens either A or B or C, then P of E equal to P of A into P of E given A plus P of B into P of E given B plus P of C into P of E given C. So this is the way. Suppose n events are there, like A, B, C, like n events are there, like this, n times you have to write it. That is called the total probability concept. So how to apply this concept in this? For example, bag 1 contains, this is the bag 1. So this is bag 1. In this, 4 white and 2 black balls. 4 white, 4 W. 2 black balls. 4 white balls are there, 2 black balls are there in the bag 1. I hope you people understand, your students. And bag 2 contains 3 white balls. This is the bag 2. So this is about bag 2. It contains 3 white, 4 black balls. A bag is drawn at random and a ball is chosen at random from it. What is the probability that the ball is white? So probability of selecting the bag important, as well the probability of selecting a ball from the bag itself also important. So here two bags are there. A bag is drawn at random. So the probability of selecting the bags, two bags are there, one bag we can select. So head and tail is there, two possibilities. Getting head is what? 1 by 2. Similarly, selecting the bag among the two bags, selecting one bag. Suppose P of B1. P of B1 is equal to the probability of selecting the first bag. The probability of selecting a bag 1. So total two bags are there. One bag we can select. It can be done in 1 by 2 ways. So P of B1 is equal to 1 by 2. So P of B2. So the probability of selecting a bag 2. Even this is also among the two bags, one bag can be selected in 1 by 2 ways. So probability of selecting is bag is over. Now, here we are assuming that the first step completed, selecting the bag completed. Now, capital E be the event, capital E be the event that drawing the ball, drawing a ball is, which ball they are asking? White. E be the event that drawing a ball is white. Here two possibilities are there. So what are the possibilities? The ball is white either from bag 1 or either from bag 2. So the probability, the event that drawing a ball is white either from bag 1 or either from bag 2. So what is the probability? The event that drawing a ball is white from the bag 1. See here, P of, here the first possibility I am writing here, students. The first possibility, B1 here I don't know. P of E by B1, the meaning of P of E by B1. E represents what? The probability of drawing a ball is white. Given that it is selecting from which bag? First bag. So P of E by B1 is the probability of selecting a bag, selecting a ball, selecting a white ball, particularly selecting a white ball from bag 1 is bag 1, no need to write is the probability of selecting a white ball from bag 1. So in the bag 1, total how many balls are there? 4 white balls, 2 black balls. So 4 plus 2. So 6 balls are there. From 6 you can select 1, 6C1. Which ball we have to select? White ball. So how many white balls are there in the bag 1? 4. Out of 4 we can select one ball in how many ways? 4C1. Which is equal to 4 by 6. That is equal to 2 by 3. So therefore the probability of selecting a white ball from the bag 1 is 2 by 3. Similarly, the probability of selecting a white ball from the bag 2, the probability of selecting a white ball from bag 2, which is equal to, so total how many balls are there in bag 2? 3 white plus 4 black, so total 7 balls are there. From 7 balls we can select one ball in 7C1 ways. And white balls, how many white balls are there? 3 white balls are there. From 3 white balls we can select one white ball in 3C1 ways. So 3 divided by 7. So how to get that total probability? How to apply total probability for this question? The doubt will arise. Almost end of the answer. What is the probability that the ball is white? The probability of selecting a ball is white from the bags, is P of E is equal to, observe dear students, P of B1 into P of E by B1. This is the way we are to apply. Plus P of B2 into P of E by B2. Both the answers we have. P of B1, what is P of B1? 1 by 2. P of E by B1, 2 by 3. Plus P of B2, 1 by 2. P of E by B2, 3 by 7. So here, 2 get cancelled, 1 by 3 plus 3 by 14, 1 by 2 into 3 by 7. LCM is 42, 3 14s, 14 into 1 plus 14 3s are 3 3s are 9, which is equal to 23 divided by 42. So therefore, the probability of selecting a ball is wide from the bags is 23 by 42. This is the way we can apply total probability. We'll take another question based on this concept from the exercise 9C. The next question, dear students. This is exercise 9C, first bit, question number 3. This is also related to total probability concept. There are 3 black and 4 white balls in one bag. So in the bag 1, this is the bag 1. In this, 4 white and 3 black. 3 black, 4 white balls are there. In the second bag is the bag 2. In that, 4 black, 3 white. 4 black, 3 white balls are there. This is the situation. A die is rolled and the first bag is selected. If die shows up 1 or 3, that means the probability of selecting the bags among the first bag is mentioned, first bag. The probability of selecting the first bag, that means P of B1, given that instead of writing given that, just P of B1 directly. P of B1 is equal to the probability of selecting the first bag. The probability of selecting first bag. When the first bag is going to select first bag, when die shows up either 1 or 3, shows up the numbers 1 or 3. So total, when if you throw a die, you will get either 1 or 2 or 3 or 4 or 5 or 6. Among the 6, 2 numbers are turned up. So out of 6, 2 numbers are getting, means this probability is P of B1 is equal to 2 by 6, which is equal to 1 by 3. And the second bag for the rest, that means the probability of selecting the second bag when die shows up either other than 1 comma 3, what are the possibilities? 2, 4, 5 and 6. So P of B2, the probability of selecting second bag, the probability of selecting a second bag when die shows up, either 2 or 4 or 5 or 6. So total 4 are there. We can write as 4 by 6, that is equal to 2 by 3. Therefore, P of B2 is equal to 2 by 3. I hope you understand that, dear students. Next, E be the event of selecting a black ball from the selected bag. Here, E be the event that, are you able to see? 1 minute. Yeah, just write one statement. E be the event that selecting or drawing a black ball, selecting a black ball from the bag selected, from the bag selected. Selected, why we are saying means either from first bag or second bag. And come to the P of E by P1. The probability of selecting a black ball from bag 1. In the bag 1, total how many balls are there? 3 plus 4, 7 balls are there. So total 7C1 in the denominator. How many black balls are there? 3 black balls are there. So from 3 we can select 1, 3C1, that is equal to 3 by 7. This is about the probability of selecting a black ball from the bag 1. That is P of E by B1. Now P of E by B2, the probability of selecting a black ball from the bag 2. So in the bag 2, how many number of balls are there? 4 plus 3, 7 balls are there. So from 7 we can select 1 ball. How many black balls are there? 4 black balls are there. From 4 we can select 1, 4C1. That is equal to 4 by 7. After that, the probability of selecting a ball is black. This is the previous step, that is the reason. From the bag is selected. From the bags are selected. So P of E equal to P of B1. So P of B1 is 1 by 3. So P of E by B1 is 3 by 7. Plus P of B2, 2 by 3. Into P of E by B2, 4 by 7. 3 by 21 plus 8 by 21, which is equal to 11 by 21. So the probability of selecting a ball is black from the selected bags is P of E is equal to 11 by 21. I hope you people understand now. We'll move on to the other problems in this exercise 9C. Yeah, next question number 5. If A, B are two events, then show that P of A by B into P of B plus P of A by B complement into P of B complement is equal to P of A. We have to prove this one. So consider for this LHS. So P of A given B into P of B plus P of A given B complement into P of B complement by definition of condition probability. P of A by B can be written as P of A intersection B divided by P of B. So this value P of A by B can be written as into P of B plus again by definition of condition probability P of A given B complement. So P of A intersection B complement divided by P of B complement into P of B complement. So P of B get cancelled. P of B complement get cancelled. So P of A intersection B plus P of A intersection B complement. So P of A intersection B complement, observe dear students in this Venn diagram. See here, A A, B are two events in the sample space. Yes, this is the common part. A intersection B it is. So in the A event, if you separate that A intersection B, this value, this space from here, the shaded region, whatever here it is. This shaded region is A intersection B complement. That means from here to here it is A. In this A intersection B we are eliminating. So the remaining is A intersection B complement is, this can be written as A minus A intersection B from the figure. So this is A intersection B complement. So from that A minus A intersection B. So P of A intersection B plus P of A intersection B from set theory, set theoretical distribution. Yesterday we discussed in the class, in the same video, in the video. A intersection B complement you can write as A minus A intersection B. By using axiom of unity, we can write it as P of A intersection B plus P of A minus B can be written as P of A minus P of B. So by using axiom of unity, P of A minus P of A intersection B. So plus P of A intersection B minus P of A intersection B get cancelled. We will get it as P of A, which is the required. So RHS. I hope you people understand, dear students. We will move on to the next question. Yeah, question number 8 in the first bit, exercise 9C. This is also related to this Venn diagram only. If A, B are two events in an experiment and P of B should not be equal to 1, show that P of A given B complement or A by B complement equal to P of A minus P of A intersection B by 1 minus P of B. It may comes for 2 marks or 4 marks, dear students. So A, B are two events in the experiment and P of B should not be equal to 1 is given. Show that P of A complement, A given B complement. Consider LHS P of A given B complement. By definition of condition probability, P of A given B is P of A intersection B by P of B. So similarly, P of A given B complement can be written as P of A intersection B complement divided by P of B complement. So P of A intersection B complement by P of B complement. Again, A intersection B complement from the Venn diagram we can write as A minus A intersection B. So which is equal to P of A minus A intersection B by P of B complement. By axiom of unity, P of A minus A intersection B can be written as P of A minus P of A intersection B divided by P of B complement from the definition. P of B complement is 1 minus P of B. This is the required RHS only. No? We got that RHS. Hence the result. We'll move on to the next question. Yeah, the next question, dear students. A single die is rolled twice in succession. What is the probability that the number showing on the second toss is greater than that on the first rolling? A single die is rolled twice. Here, a single die is rolled twice in succession. We get the total possibilities. We get the total number of possibilities. The total possibilities n of s is equal to, see, single die is 6. Twice is rolling succession. 6 into 6. So 6 square, that is equal to 36. So we know that what are the possibilities of that 36 is 1 1, 1 2, 1 3, 1 4, 1 5. 1 6 like this, 2 1 2 2 2 3 2 4 2 5 2 6 and so on, 6 1 6 2 6 3 6 4 6 5 and 6 6. These are the possibilities of these 36. Out of these 36, what they are asking is, what is the probability that the number showing on the second toss is greater than that on the first rolling? So let E be the event that, let E be the event that the number showing on the second toss is greater than that on the first rolling. So what are the possibilities of E? I am writing here, dear students. So if you take that 1 comma 2, second, here the number of showing on the second toss is greater than first toss. 2 is greater than 1. 1 3, 1 4, 1 5, 1 6. Next 2 3, 2 4, 2 5, 2 6. Next 3 4, 3 5, 3 6. Next 4 5, 4 6. Next 6 6 it won't come. 4 comma 6. Next 5 terms will come now. 5 comma 6 only possibility. 6 is greater than 5. There is no other possibility. Even 6 1 6 2 there is no possibility in the 6. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So n of E is equal to 15. Therefore the required probability so P of E is equal to n of E by n of S. So what is n of E? 15. N of S is 36. So 3 5s are 3 12s are. So therefore the required probability for the given event is 5 by 12. We'll move on to the next question. The next question is, students, if one card is drawn at random from pack of cards, then show that event of getting an ace card and getting heart are independent. So we have to prove the two events are independent. Suppose if I am selecting a card from an ace, I am taking as E1 event. Getting hurt card is I am taking as E2 event. So we need to prove P of E1 intersection E2 is equal to P of E1 into P of E2. This is our aim. See how we are going to do that. Let E1 be the event that selecting a card is an ace. So total how many ace cards are there? So total 13 13 13 13, like 4 sets of 13 cards are there. In every 13 sets one ace card is there. So from these 4 sets 4 ace cards are available, and that these 4 cards will be, from 4 cards we can select one card in 4 C1 ways. Before that, how many total number of cards are there? Pack of card contains 52. So from 52, n of S I am writing here. These are the total number of cards. From 52 we can select one. It is in 52 C1 ways. Therefore n of S is 52. Now come to the event E1. N of E1 is equal to. So total in every 13 set of 4 set of 13 cards, 4 A's are available. From 4 we can select 1. It can be done in 4 C1 ways. Therefore 4. The probability of E, P of E1 is equal to N of E1 by N of S. So 4 by 52, that is equal to 1 by 13. So P of E1 value is over. Now take that E2 event. Let E2 be the event that selecting a chord is heard. So 13 set of heard chords are there. So from that we can select one. Therefore it can be done in 13 C1. So it can be 13. So therefore the probability of getting the chord heard is P of E2 is equal to N of E2 by N of S, that is equal to 13 by 52, which is equal to 1 by 4. 13 ones are 13 fours are. Next, E1 intersection E2. So here one ace card is there. In 13 also one ace card is there. So one ace card, it will be only one. So E1 intersection E2 is commonly from ace, and here from hertz. One ace card is there. One ace card. So the N of E1, cardinality of E1 intersection E2 is equal to 1. From that we can select 1 means 1 C1, which is equal to 1. Therefore, P of E1 intersection E2 is equal to 1 by N of E1 intersection E2 by N of S. So which is equal to 1 by 52. Now we have to prove that P of E1 intersection E2 is equal to P of E1 into P of E2. Now P of E1 intersection E2 is equal to 1 by 52. Keep that equation number 1. We got it. Now I am calculating P of E1 into P of E2. So these values 1 by 13 into 1 by 4, which is also equal to 1 by 52. From 1 and 2 we conclude that from 1 and 2 P of E1 intersection E2 is equal to P of E1 into P of E2. That implies that E1 comma E2 are independent events, hence the result, or hence proved. They are asking to prove the result of independent events, these two are. So I hope you people understand this, students. From question number 12 to question number 20, I will make another video. Thank you for watching. Thank you for your support. Signing off, Maths with Panindra. Jai Hind.